for you, please.
Okay.
All right, are we ready?
All right.
All right. Hello, everyone, and welcome to tonight's session of the November to Remember talk series. My name is Amir Abbas. I'm a lecturer here at the university. I'm really glad to see so many students joining us today. The whole November to Remember series, we've been running it for the past 3-4 years under the guidance of Dr. Celestine, has been spearheading the whole program. And this series is about exploring exciting new ideas. It's about sharing knowledge. It's about connecting across the university's community. Okay, so today's focus or tonight's talk's focus is something that is important to all of us, right? We will be talking about artificial intelligence and agents, right? AI is no longer something just from science fiction. It's quite literally shaping the way we live, shaping the way we learn and the way we work. Understanding AI and understanding autonomous agents, it's crucial because they are transforming industries, they're driving innovation, and they're also challenging the way we think about solving problems. So for all the attendees here today, whether if you are curious just about how these technologies work, or if you're wondering about the impact that these agents or the technology is going to have in your future, today's talk is going to help us unpack some of those questions in the field. We're all lucky to have Dr. Vandana Sharma with us, who is a top expert in AI. She's recognized amongst the world's top 2% of the best scientists and is working across some amazing projects globally. She's going to be sharing with us what agentic AI is, why it matters, and where it is heading. Okay. In terms of today's program, overall, we'll just start off with the introduction. Then I will hand over to Kimberly, who is our ambassador for the day, who's going to take over the rest of the program. She will introduce our guest speaker. We'll have the main talk from Dr. Sharma, and then we will move on to a Q&A session. So anytime you guys have any sort of questions, just have them ready to go. Raise your hands when you have those questions or put them up in chat. And then we'll finish up with some closing remarks and awards. All right. So with that brief introduction, I want to hand over to Kimberly, who's going to guide us through the next part of tonight's event. Kimberly, this is all yours.
Good evening, everyone. It's an honor and a pleasure to be the ambassador for today. So I'll just get right straight into it and introduce our speaker for the night. So I'll share my screen now. Please do let me know when you can see my screen, okay? Please, can you see my screen?
Yes.
Yes, we can.
Okay. So our speaker today is Dr. Vandana Sharma, who is an associate professor at Christ University, Delhi. About her, Dr. Vandana is recognized in the Stanford list of the top 2% of scientists in the year 2024 and 2025. She is an accomplished academician and researcher, serving as an associate professor at Christ University, Delhi, NCR Campus, India. She's a senior member of IEEE. She has an impressive publication record with over 150 research papers in esteemed SCI and Scopus-indexed international journals and conferences. She actively contributes to the academic community through various roles, including keynote speaking, session chairing, reviewing and participating in technical program committees for renowned international journals, and IEEE conferences. She holds a postdoctoral degree from Lincoln University College, Malaysia. So welcome, Dr. Vandana. We're very happy to have you here today.
Thank you so much for the lovely introduction and briefing on the topic today. And I'm really very glad to be part of November to Remember series. And I'm thankful to Dr. Celestine for inviting me one more time. So last time also I was part of the series, and this time also I'm fortunate enough to be here and deliberating on today's topic. So when I was thinking of taking a topic and talking about something new in the industry, then I have come across with this particular topic, which is known as agentic AI. So it's a new buzzword, but we need to understand what's the buzz behind it and what makes agentic AI. So the talk for the today is going to be very simple in terms of understanding the working of agentic AI. And with that, we will understand what agentic AI is, how it is changing the way LLM models are working, and how it is different from the generative AI, which is already in place. So we are going to deliberate on that in next 50 minutes, and the last 10 minutes we can open it for the question and answer, if any, from the audience. So I'm Dr. Vandana Sharma from Christ University, India, and I'm here to talk about agentic AI, making you understand that how it is different from generative AI and its application. So the entire talk would be divided into these sections. The outline of my talk is basically dependent on what is the reason of rising of generative AI, from generative AI to agentic AI, how the agents actually work in agentic AI model, what are the key implementations and steps for agentic AI, the useful resources which can be used by for the beginners, so from where they can actually start working on projects focusing on agentic AI, how it is being implemented, and the industries which are affected, I can say, or maybe the industries where the applications of agentic AI is very much pertinent. So these all things we are going to cover in the session today. So let's start with the rise of generative AI. So we already know it started almost 3 years back, where the growth of AI adoption was seen across various sectors. And with 100 million plus users for LLM models and the GPTs like ChatGPT, Midjourney, or Copilot, the shift was from prediction to prescriptive to generative intelligence. So initially, we were applying ML models to predict the future, of predict the vulnerabilities or predict the anomalies. Now we are prescribing the solutions for those anomalies. And now we in the world of generative intelligence, which is now a new creative collaborator for us. Now, generative AI in picture, if you'll see that in general, we know that generative AI is being used for creation of text, images, code, designs, and they are basically powered with the help of foundation models. The foundation models with respect to LLMs for generating text, diffusion models for video and images, and GANs. Now here, learning from a pattern and generating a new output. This is what generative AI is doing. So it is basically focusing on a task given from a prompt. So if you're prompting well to generative AI models, you are getting certain output. But those outputs are not integrated in terms of a solution. Okay. So here, inside generative AI engines, you will find there are three you can see three ways which we are trying to get the information. Either it is from the LLMs or diffusion models, and with the human intervention. So the human intervention is in terms of how the human is giving feedback. So whenever we are generating data, we are giving feedback to these models. So it is more dependent on the type of prompts being given, and it is more dependent on the type of data which is fed into these models, right? And it is focusing on one specific task. Now, till now, we were good and we all were part of, I can say, either generating the data, generating the code, generating images, text for a specific maybe task, but not the collaborative one. So now we need to understand that how generative AI is different from agentic AI. So this is one short video which I wanted to share with all the participants here, where they can understand the major difference between generative and agentic AI. The source is from IBM.
What's the difference between generative AI and agentic AI? Well, they're two distinct approaches to artificial intelligence. And I think we're all familiar with generative AI, things like chatbots and image generators and the like. And they are really fundamentally reactive systems. They wait for you to do something. Specifically, they wait for you to prompt them. And once you prompt them, their job is to generate some kind of content based upon what you provided in the prompt. And they're using patterns they learned during training. Now, the things that it can generate, well, that might be some text, or it might be an image, or it might be a piece of code, or it might be some audio. These are all sorts of things that we can generate with generative AI. And they're essentially sophisticated pattern matching machines. They've learned the statistical relationships between words and between pixels and between sound waves. And they've learned that from massive data sets. So when you provide a prompt, Gen AI predicts what should come next based on its training. But its work does end at generation. It doesn't take further steps without your input. Now, agentic AI systems, by contrast, those are not reactive, they are proactive systems. Now, like generative AI, they often start with a user prompt, but that prompt is then used to pursue goals through a series of actions. And an agentic system basically goes through a bit of a life cycle. So the way this works is it kind of, first of all, perceives its environment, if you like. And then once it's done that, it can decide an action to take. Once it's decided that action, it can then execute that action. And then once that action has been executed, it can kind of learn from the output, and then round and round we go, all with minimal human intervention. Now, both of these AI approaches often share a common foundation, and that common foundation is large language models, or LLMs. LLMs serve as the backbone for chatbots. And yeah, there's actually other tools that are used for some of these other generative things, diffusion models typically for images and audio. But for chatbots, we use LLMs. And LLMs also provide the reasoning engine that powers agentic systems. But before we go any deeper into that, let's talk about some real-world applications and use cases. Now, maybe this doesn't put me in the best of lights, but I don't think I'm the only one using generative AI to help with the task of content creation, and especially creative content creation. Now, before work this morning, and this is completely true, I used the chatbot to help write the next chapter of my Nelson DeMille fan fiction novel. And right now you're probably thinking how profoundly cool and absolutely non-nerdy this guy is. But for many of us, Gen AI does help with daily tasks. Like, let's consider how a YouTuber might use a generative AI system to review scripts and suggest thumbnail concepts and maybe even generate background music. But at each step, there is a human. There is a human creator. And that human creator is looking at this generated content and they are reviewing it. Check it's what they want. Probably isn't. So then they are refining it as well. And they are really going through and directing this whole process. The AI generates possibilities, but the human curates them. Now, agentic AI, that kind of thrives in scenarios that require ongoing management and consist of multi-step processes. So not just one thing at a time. So consider a personal shopping agent. Given a product to purchase as input, it actively hunts for availability across platforms. It might monitor price fluctuations. It might handle checkout processes, and it might even coordinate delivery. Largely by itself, seeking input only from you, only when it's needed. But how does it do that? Well, it turns out that the LLMs that are behind much of generative AI can also be used to provide reasoning capabilities to AI agents. So this essentially here, we're using Gen AI's ability to kind of think in inverted commas there.
So here from the audience, I would like to know that generative AI prompt engineering, one specific prompt engineering is being used in agentic AI. So if you're well versed with the prompt engineering concepts of generative AI, you will be able to correlate that what is happening behind the scenes of agentic AI. So anyone from the audience who can answer this question? One specific kind of a prompt which is being used. So you can see one generative AI is reactive, another is proactive. One is talking about only completion of a task, whereas the second one, agentic AI, is talking about a one-point solution. And it's based on prompting. And we already know there are types of prompting available. Very specific prompting is being used to have this basis of agentic AI. Anybody from the audience? The popular prompting method used in agentic AI is chain of thoughts. So chain of thoughts talks about that you have a problem and you're giving resources to the AI agent, and then they are coming up with the solution for you, asking the human interventions in between, and taking inputs from multiple resources and not from only the LLM models datasets. These are more tailored version of solutions which you're getting with the help of agentic AI, more tailored, more specific to me and you.
And it's thinking through problems. And this has a name. It's called chain of thought reasoning. And this is what LLMs are so very good at. It's a process where the agent basically breaks down a complex task into smaller logical steps, kind of like how humans tackle difficult problems as well. So let's imagine one. Let's imagine that we want to have an agent that is planning a complex task like organizing a conference. So what it's going to do is it's going to use Gen AI to generate an internal dialogue. And that dialogue might go something like this. It might say, first, I need to understand the conference requirements, so the size, the duration, the budget, that sort of thing. Then I should research available venues matching those parameters. Then it might think, well, for those venues that meet those requirements, then I need to check availability and so on. It's effectively the agent really kind of talking to itself to explore the problem space before taking action. Gen AI is basically the cognitive engine driving an agent's decision making. Now, looking ahead, the most powerful AI systems probably won't be purely generative or purely agentic. they're going to be intelligent collaborators. They'll understand when to explore options through generation and when to commit to courses of action through agentic action. Like an agent that would know when to generate the next chapter of fan fiction so it's ready after, oh, I don't know, a video shoot. Maybe it's ready right now. What's the difference between?
So here in this video, why I have shown you this video is to make you understand the major difference between these two. So here we can see the generative AI completing a task, whereas agentic AI is actually tailoring the solution. So completing a task is like whatever the user is prompting, they're providing a solution based on the present information available. Whereas in case of agentic AI, the agentic AI solution would be more based on, okay, what do you want? What kind of solution do you want? Do you have a resource related to that? So based on that, it is going to give you a whole set of a different way of solution. And the prompting that is being used is chain of thoughts. So now you need to understand with this another video, one more video I have included here, you need to understand that how the AI agents are now being used.
AI, or agentic capabilities. AI agents, agentic workflows, agents.
All right, most explanations of AI agents is either too technical or too basic. This video is meant for people like myself. You have zero technical background, but you use AI tools regularly and you want to learn just enough about AI agents to see how it affects you. In this video, we'll follow a simple 1, 2, 3 learning path by building on concepts you already understand, like ChatGPT, and then moving on to AI workflows, and then finally AI agents. All the while using examples you will actually encounter in real life. And believe me when I tell you, those intimidating terms you see everywhere, like RAG, RAG, or React, they're a lot simpler than you think. Let's get started. Kicking things off at level 1, large language models. Popular AI chatbots like ChatGPT, Google Gemini, and Claude are applications built on top of large language models, LLMs, and they're fantastic at generating and editing text. Here's a simple visualization. You, the human, provides an input and the LLM produces an output based on its training data. For example, if I were to ask ChatGPT to draft an email requesting a coffee chat, my prompt is the input, and the resulting email that's way more polite than I would ever be in real life is the output. So far, so good, right? Simple stuff. But what if I ask ChatGPT when my next coffee chat is? Even without seeing the response, both you and I know ChatGPT is going to fail because it doesn't know that information. It doesn't have access to my calendar. This highlights 2 key traits of large language models. First, despite being trained on vast amounts of data, they have limited knowledge of proprietary information, like our personal information or internal company data. Second, LLMs are passive. They wait for our prompt and then respond, right? Keep these 2 traits in mind moving forward. Moving to level 2, AI workflows. Let's build on our example. What if I, a human, told the LLM, every time I ask about a personal event, perform a search query and fetch data from my Google Calendar before providing a response? With this logic implemented, the next time I ask, when is my coffee chat with Elon Husky, I'll get the correct answer because the LLM will now first go into my Google Calendar to find that information. But here's where it gets tricky. What if my next follow-up question is, what will the weather be like that day? The LLM will now fail at answering the query because the path we told the LLM to follow is to always search my Google Calendar, which does not have information about the weather. This is a fundamental trait of AI workflows. They can only follow predefined paths set by humans. And if you want to get technical, this path is also called the control logic. Pushing my example further, What if I added more steps into the workflow by allowing the LLM to access the weather via an API, and then just for fun, use a text-to-audio model to speak the answer?
The weather forecast for seeing Elon Husky is sunny, with a chance of being a good boy.
Here's the thing. No matter how many steps we add, this is still just an AI workflow. Even if there were hundreds or thousands of steps, if a human is the decision maker, there is no AI agent involvement. Pro tip, retrieval augmented generation, or RAG, is a fancy term that's thrown around a lot. In simple terms, RAG is a process that helps AI models look things up before they answer, like accessing my calendar or the weather service. Essentially, RAG is just a type of AI workflow. By the way, I have a free AI toolkit that cuts through the noise and helps you master essentially a LinkedIn and Instagram post. Second, I'm using Perplexity to summarize those news articles. Then, using Claude and using a prompt that I wrote, I'm asking Claude to draft a LinkedIn and Instagram post. Finally, I can schedule this to run automatically every day at 8 a.m. As you can see, this is an AI workflow because it follows a predefined path set by me. Step 1, you do this. Step 2, you do this. Step 3, you do this. And finally, remember to run daily at 8 a.m. One last thing, if I test this workflow and I don't like the final outputs of the LinkedIn post, for example, as you can see right here, it's not funny enough and I'm naturally hilarious, right? I'd have to manually go back and rewrite the prompt for Claude, okay? And this trial and error iteration is currently being done by me, a human. So keep that in mind moving forward. All right, level 3, AI agents. Continuing the make.com example, let's break down what I've been doing so far as the human decision maker. With the goal of creating social media posts based off of news articles, I need to do 2 things. First, reason or think about the best approach. I need to first compile the news articles, then summarize them, then write the final posts. Second, take action using tools. I need to find and link to those news articles in Google Sheets, use Perplexity for real-time summarization, and then Claude for copywriting. So, and this is the most important sentence in this entire video, the one massive change that has to happen in order for this AI workflow to become an AI agent is for me, the human decision maker, to be replaced by an LLM. In other words, the AI agent must reason. What's the most efficient way to compile these news articles? Should I copy and paste each article into a Word document? No, it's probably easier to compile links to those articles and then use another tool to fetch the data. Yes, that makes more sense. The AI agent must act, aka do things via tools. Should I use Microsoft Word to compile links? No, inserting links directly into rows is way more efficient. What about Excel? No, the user has already connected their Google account with make.com, so Google Sheets is a better option. Pro tip, because of this, the most common configuration for AI agents is the React framework. All AI agents must reason and act, so react. Sounds simple once we break it down, right? A third key trait of AI agents is their ability to iterate. Remember when I had to manually rewrite the prompt to make the LinkedIn post funnier? I, the human, probably need to repeat this iterative process a few times to get something I'm happy with, right? An AI agent will be able to do the same thing autonomously. In our example, the AI agent would autonomously add in another LLM to critique its own output. Okay, I've drafted V1 of a LinkedIn post. How do I make sure it's good? Oh, I know. I'll add another step where an LLM will critique the post based on LinkedIn best practices. And let's repeat this until the best practices criteria are all met. And after a few cycles of that, we have the final output. That was a hypothetical example. So let's move on to a real-world AI agent example. Andrew Ng is a preeminent figure in AI, and he created this demo website that illustrates how an AI agent works. I'll link the full video down below, but when I search for a keyword like skier, enter, the AI vision agent in the background is first reasoning what a skier looks like. A person on skis going really fast in snow, for example, right? I'm not sure. And then it's acting by looking at clips in video footage, trying to identify what it thinks a skier is, indexing that clip, and then returning that clip to us. Although this might not feel impressive, remember that an AI agent did all that instead of a human reviewing the footage beforehand, manually identifying the skier, and adding tags like skier, mountain, ski, snow. The programming is obviously a lot more technical and complicated than what we see in the front end, but that's the point of this demo, right? The average user like myself wants a simple app that just works without me having to understand what's going on in the back end. Speaking of examples, I'm also building my very own basic AI agent using NAN. So let me know in the comments what type of AI agent you'd like me to make a tutorial on next. To wrap up, here's a simplified visualization of the 3 levels we covered today. Level 1, we provide an input and the LLM responds with an output. Easy. Level 2, for AI workflows, we provide an input and tell the LLM to follow a predefined path that may involve retrieving information from external tools. The key trait here is that the human programs a path for the LLMs to follow. Level 3, the AI agent receives a goal and the LLM performs reasoning to determine how best to achieve the goal, takes action using tools to produce an interim result, observes that interim result, and decides whether iterations are required, and produces a final output that achieves the initial goal.
So here, with the help of this video, you will be in a, I can say, position to differentiate between the working. So you will find generative AI process very lame. You might find that it's no more, no more in picture, and we need to have more AI workflows in the implementation. And you might also be thinking that, yes, it will now be better to have agents, AI agents working for the solutions today. So now the next question here is how you're going to implement it. That's another question. So as a researcher, as a person who is exploring the agentic AI for the very first time, what all steps are required? So you need to start designing an agent that is completely independent. So independent in terms of perceiving the information, planning it out, deciding, there are deciding factors, and then learning from the response and the goal, the ultimate goal for which the AI agent is supposed to work. So for example, if I have to plan my entire week, so the agent will be first perceiving information independently about my calendar, about maybe the flights, about maybe the classes, maybe the university schedule, and then also the other engagements I might have, maybe watching a movie with my friends. Those all information taken together, and then the AI agent must plan and tell that, okay, you can plan this particular activity today and not tomorrow, based on the decision being made. So the first one would be starting with designing an agent that will think independently, and the humans are going to give a feedback whether it's good enough for them or not. The second would be setting the clear goal. So it should be specific. The objective should be very specific. What exactly you want? A planner tailor-made only for you, or maybe a conference calendar planning for the next year, or maybe optimizing a workflow. Then after that, gathering information. So gathering information in terms of not static data, but the real-time data, the real-time weather forecast, the real-time calendars, the real-time maybe flight schedules, the real-time maybe the planners, everything. And it can be based on the data sets which are being generated from either sensors or from user inputs, so that these AI agents can actually perceive information, which is very important for them to take a decision. Then the third would be creating a perception module. So integrating all information together, making these AI agents aware, and then using tools like, say, computer vision, or maybe natural language processing, or various APIs which are available. Now, once you're done with that perception, now the goal representation and planning. So how you are going to break the task, prioritize the action, and give a solution with the reasoning. So then you need to have a decision making, decision making module where AI is reasoning whether the data is latest enough, whether the data is frequent enough in terms of understanding, in terms of its completeness. So these information has to be there while making a decision, and then selecting the optimal action. Now, the next would be the action module, which is actually executing the task in real environment or in virtual world, but integrating all information together. So it can be based on the APIs, as I told. It can be based upon the data that we are collecting from sensors. It can be from the data from our calendars. It can be data from our other planners, or the news around us, the happenings, the real-time happenings around us, and then handling the errors and verifying the results. And then the last would be the AI agent need to learn and memorize. So need to learn the outcome, adapt it according to the time, over time, because it is going to change, and then improving and learning and remembering the decisions being taken. Now, all this information again connected and integrated with the existing system. So we cannot have implementation of technology by completely building the new one. We have to have a backend, we have to have the backward implementation and acceptability with the existing system. So connecting these agentic AI is going to be the next, I think, next big task already in process in the year to come. So here the existing softwares will be now connecting with the agentic AI. The databases, the hardwares will be having seamless information and task execution, and then deploying and definitely monitoring the feedbacks and the new data. So this will be a complete workflow, how to implement it. Now, take an example of, say, a simple pseudocode I have given here, where you can start thinking how the agentic AI is working. So the first one would be perceiving, second would be planning, acting, learning iteratively, and again perceiving, then planning, then acting, and then again iteratively learning from it. So here you can see a small pseudocode here where the goal is to prepare a presentation on AI. Now the agent has to take an input of that goal, okay, preparation of an AI. Now, what is the task right now? How is the environment? Whether it is for what kind of students or what kind of background or what kind of person who is going to prepare or deliver, and then perceiving it from the environment observations, the previous inputs by the user, and then planning it together, seeing the next execution or the task, and then preparing the result. And again, there's a human intervention. So it is not like that information is going to be individual, it is going to be a human intervention. Now, the practical recommendation for building such kind of AI frameworks, we need to have pre-built modules, which is going to simplify the process, simplify the integration with the existing, simplify the orchestration where everything is integrated, and seamlessly handle the errors if in case it happens so. And then implementing for data curation, for workflow, for decomposition of identity, and the assigning of tasks. So everything has to be in place with AI agents integrated with the existing workflow. So we are not going to create or build something new completely, but we are going to improvise to give tailor-made solution based on these steps. Now, these are certain useful links I would like to share. So some of the links are already placed here. So one of them, from where you should start now to start learning, to start exploring the resources. So I have given here 6 good resources. The very first one is Agentic AI, building the Agentic AI, very small one with the help of Python coding. Another is about a blog on agentic AI architecture and the various architectures which are in place, how it is being modeled, and then guide to agentic AI, then data engineering and the workflows of agentic AI. And there's a handbook, agentic AI handbook, which is available. And it's that the read is very simple. I can show you the links here, starting from you are building the AI with the help of codeware. There is an architecture here. You will find the agentic AI architectures, how it works. So there are different set of architecture. Not all agents are working in the same way. So one is of type perception, another is of type goal, another is of type planning, decision. These are the basic steps, and you will find various modules which can be adapted based on these readings. Then building the agentic AI, building agentic AI architectures, already 5 are in place. You can also, if you are a researcher, you wish to work on agentic AI, you can also think of working on a new architecture altogether to improvise. Then understanding on how this agentic AI works. This is a nice read, a blog for understanding it. And here we can see the agentic AI workflows. So from, again, the way I have already explained you, it is about understanding, then planning, integrating, executing it, handling the problem, and learning for the future. So these are few links which I have. I'll be sharing my PPT so that everybody can have an access to these links to start with. And here, some of the applications. So as I told you that we are not going to build something new. We are going to improvise with the help of agentic AI. So as you have seen, LLMs already in place. You are already generating text, videos, audios, images already. We are generating codes, we are generating data sets, synthetic data sets. We're already in place generating so much, but it is all one task oriented. So now adding it to AI workflow where we are providing steps to build it further, and then again making it an advanced version of it where we are implementing agentic AI. Now, where we are going to implement it. So these are the sectors, prominent sectors, the way we are implementing LLMs in the manufacturing, healthcare, finance, education, media, IT, and public sector. The same way agentic AI is going to be integrated in the same way. Now, the time to reflect, you need to understand that what exactly is going to happen. So you can think of, because the audience here is from different backgrounds. So now you can think of one task in your field that agentic AI could transform. So after understanding the difference, you need to think, okay, what particular task you were doing till now, you were not getting the exact results, what you were expecting. So what else can be done? How the workflows can be changed? What kind of integration can be done in the present form? Now, the collaboration. So there was a question when I used to give talk on when we were 2 years, 3 years back, we used to talk about generative AI implementation, LLM models, ChatGPT, Copilot. That time there was a deliberation that whether humans are being replaced with AI or whether AI will be more prominent and what will happen to the jobs, what kind of things will happen. But the picture is quite clear now. The picture is clear that AI is not going to replace anyone. The only thing is, the harsh reality is that AI won't replace professionals, but professionals who use AI will replace those who don't. And it is for everybody. So today, professionals, be it from the applied sciences or maybe law professionals, everybody has to use it and has to use a tailored version for themselves. So this is what I wanted you people to reflect on. and the last wrap up and QA question. So now you can reflect on these two questions, that where do you see generative AI and agentic AI making the most impact? And how can we balance the creativity and control? So who is going to control and who is going to implement the creativity? You have to reflect on these two questions now. And that's all from my end. And if you have any questions, you can ask me. Thank you so much. Yes, I think I have a question from Samuel. You can
Good evening,
unmute
Doctor.
yourself.
Another insightful evening, and then thanks for your time and the effort you took to took us through the story. It was well received. My question is on the automations using the models and within the AI. Is it free? Because I know most of those requires API calls, and all those API calls come with cost, even though it's going to save human lots of time in building those agentic AI workflow. But at the end of the day, the cost is enormous.
Okay.
Hello, Doctor. She's frozen.
I think she's facing some connection issues, Samuel, right? So let's just wait a few moments for her to get back, right?
When we deliver the agentic AI in WTO, it's absolutely a big one because we wanted to use Copilot to do it. And using Copilot, we were able to, allow those agents, just like the speaker was saying, as we were waiting for her, did some tests to much more like project how the WTO system can work without,
I think she's
without interference,
Yeah, she's
But one of the questions you've just asked now is to, the problem that comes up. And one of the problems someone asked was, what if agentic AI goes to answer what you did not send it to do? Just like the speaker said, it has to do with data. Agentic AI will not go more than, you have to train it. It works by pattern. And that is the idea. It works by pattern. It's just that it's just going to do the work for you, but it knows your routine of what to do. Dr. Vandana, are you back here?
I think I accepted.
She came in and then
Yeah,
left
I
it.
think I accepted. She's here, but as VS. Is she VS or someone else?
Previously she was VS, but I didn't see her pop into the waiting room now.
I accepted her.
Yeah, absolutely.
Yeah, she is joined in.
Okay, just release her.
Yeah, hello. Can you hear me?
Yes, we are trying to release.
Yeah, the video I cannot.
Just
start
give
my
us a
video.
few seconds.
Okay, no problem.
Okay, you need to make a co-host.
Yeah. Okay. Yes, we can now see you.
Okay, yes. So I'm really sorry for that glitch. I really do not know how it happened. So my system completely shut down. So, okay, yes. So Samuel was asking a question. I completely missed on. Could you please repeat?
Thank you very much for coming back. My question was that with this agentic AI, we have many integrations being put together, even though it makes life easy for me and you. At the end of the day, the cost is enormous when you start building those agents.
Yes, of course. If it is going to be a tailor-made solution, definitely the cost is going to be there.
Yeah. So
See, it's very simple to understand. So if it is the solution is being adopted by masses, the cost will be very less. But initially, when the technology comes in place and it is only for few people to implement and understand and grasp it, definitely the cost will be higher. But we as researcher, we are not worried about the cost. We are more worried about its, its evolving and its generation.
thank you.
Yes. Any other question from the audience? But to start with, Samuel, you can always start working with the free tools, I can say, the implementations with Perplexity, you can try. And the links I'm going to share, I can share it here also in the chat window if I'm allowed to paste information in the chat window. Let me see. No, I'm not allowed to paste anything here. So I'll be sharing my PPT so that it can be shared with all the participants. There I have provided the links and they are in flow. You can start from the very first one till the end and you can come up with your own agentic AI implementation to start with.
Thank you for the information.
Thank you for asking.
Hello, everyone. Good evening. Good evening, Dr. Vandana.
Good evening.
Thank you so much for finding time to join us this evening. So I have a question. This topic is both fascinating and current at the same time. And my current dissertation is actually in this field. So I want to ask, what's the difference between agentic AI and AI assistants?
See, it's the matter of the terminology that you're using right now.
Okay.
If I say in terms of its implementation, agentic AI is talking about adding one more layer to the present AI workflows. One more layer of having reasoning with the agents towards a goal. So say, for example, we'll take your example. Okay, so you have this November to Remember series in place. You must have, as a team, decided upon the dates, that when are you going to do it. The next would be the timings. The next would be the set of speakers. The next would be calling participants, publicizing about it. So there are so many steps, am I right, to plan such an event internationally where anybody can join from anywhere. Am I right?
Sure, yeah.
Yeah. So also in the beginning of the lecture, Professor Celestine was telling me that there were few people who have joined and they have interrupted the session. So now do you have ways? It was all manually done, right? So do you have ways where you can actually allow or disallow people
Yes.
automatically? There are ways to implement those. So those are those implementations which are tailor-made, handling most of the exceptions and working for you will be part of agentic AI rather than human intervention is there. So we know that for an online platform where everybody or anybody can join with the help of meeting ID and a password, it's very difficult it's very difficult to control the environment. But with the intervention of agentic AI, with the intervention of AI workflows, definitely we can do that. So as an administrator, your task will be only to, give a guideline that only these many are allowed users and only these can attend or these can only join. If they're joining before, say 6 p.m., it's fine. If they're joining at 6:01, nobody is allowed. Meeting is closed. Nobody will bother. There will be no caption telling that, okay, somebody is waiting in the waiting room. These captions should also not be a part of the meeting. Are you getting my point here? So you are automating. So the agentic AI is going to do that for you. But at the background, there's more and more coding that you're doing for adding these workflows to the existing implementation. You're adding more workflows. You're adding more layers of, decision making.
Okay.
I hope I have answered your question.
Yeah, I was also wondering, since these AI systems start making decisions on their own,
Yes.
how can we balance autonomy and accountability?
Okay, that's an interesting question. And accountability and one more term that I have used is credibility, right?
Autonomy.
Autonomy. Okay.
Yeah.
So when we say they're working on their own, this is not the case. They're not working on their own. Am I right? These AI systems, these autonomous systems are built on predefined workflows. And those predefined workflows are from the developer itself, like you and me. We are defining those workflows. We are telling to take the data from here, maybe from a sheet, maybe from the calendar, maybe from your planner, and then decide and then give an output. Are you getting my point? Giving all the resources, already defined workflow, and then getting an answer back from. So autonomy is there. As the last slide I have already shown that it's not about AI doing everything. Please try to understand. The background is not like that. The background of the implementations are not like that. They are completely structured, logical. There is a flow on the basis of which we're getting certain output. So for a person who is not from the computer science or applied sciences, may think that it is all AI what is doing, but no, it's not like that. They are being programmed and coded. Am I right? So autonomy is always in hand of, of humans by the end of the day, how they want their solutions to be.
Okay, that's right. Thank you so much.
You're welcome.
Thank you very much for those questions. I think those are quite a few thoughtful questions over there, right? I want to just thank all the students for joining us tonight and helping make this session a successful one. We're at about 80 participants, so that's a really good number to see. And I just want to express a special thank you to Dr. Vandana for your very insightful talk, right? And I'm very certain that all of the students are thinking about AI, about autonomous agents, maybe as a part of their coursework, maybe as a part of their research, and maybe even sort of considering things in the AI space for future careers, right? So for all of us students who are there here tonight, the ideas that were shared have been a fantastic starting point for your own projects and explorations. And I think Dr. Vandana has also shared a few links in her slides that should give you a good starting point, right? And I know that we have a varied audience today. So we have students who are at the start of the program, we have students who are working at their dissertation, and we have students who are sort of like in the middle of their programs as well. So given that we have such a diverse audience, right? I think everybody's going to think of this in different ways, and I encourage all of you guys to consider how agentic AI could help bring sort of new solutions to existing real world problems, right? So I want to encourage all of you guys to learn and use the stuff that has been covered today to sort of push your own thinking and take your creativity, a few more levels higher, right? So before we end, to help us celebrate and to recognize all of Dr. Sharma's outstanding work and the fantastic presentation that we had today, I want to invite Dr. Celestine to present the award. Professor Celestine, over to you.
Yeah, thank you so much, Dr. Vandana. This is, I'm much,
Pleasure is all mine. Thank you so much.
Very excited how you took up this as a very short notice, So we are really glad on behalf of the head of school, who is unavoidably absent due to some other engagement. We want to thank you, from the School of Creative and Technology and from the Center of Intelligence of 10. On Tuesday, my last week, Madam DG WTO was saying that this year, 2025, has been named the year of agentic AI. So it's a very good thing. And then the first agent was created in December. And now even in our lab here, we are already working with those agents, and we've been able to deliver this lecture to WTO. So we are really very thankful that you decided to deliver this today. And then we are glad the YouTube will be out, and then we'll share it more to our students to pick up those links and learn more. Thank you so much. So I want to say a big one as we share what we have for you. I don't know if everybody can see this. Okay.
It's starting, Dr. Celestine. We're almost there. Yes, we can.
Yes. So this is our e-plaque to you to say thank you so much. I'll send it also to your email. November to Remember series of talks 2025 awarded to you in this area where we have been looking at powering possibilities, technology, trade, and the future of human development. Thank you so much. We appreciate you again.
Thank you so much, Professor. And I'm glad to see Negin and Amir and Salome and Samuel and yourself. Thank you so much for being here, hosting me. And I hope to be part of November to Remember series for next year also. I'm self-inviting myself for that. And I'm really excited. Thank you so much.
Please, everyone, you're free to connect with her online. She has a very big follower online. And then in terms of collaboration, she has many books. She has many books that she has published. And we'll be glad to host her next time, even in the physical at the University of Greater Manchester.
Looking forward.
Thank you. Over to Ami. Final word.
Thank you so much, Dr. Vandana. It was fantastic having you over for the thought. And I think you've given a lot of food.
Your voice is muted.
I'm so sorry. Dr. Vandana, thank you so much for coming in for today's session. And you already pitched a few ideas for students, at least a few frameworks that they can sort of look at. For the students who are heading to their dissertations, I think you've made life a little easy and given a fantastic starting point, right? So thank you so much for taking the time to come join us today. And I understand that, it's quite late in India. You're about 5 hours ahead of us. So thank you very much for burning the midnight oil and making the time to give the talk to us. Thank you so much.
Thank you once again. And at the end, I would like to mention one thing, that In past so many years, I have seen changes in the projects. Now, this year there was a huge change where students were given, I was teaching cybersecurity, and students were given many projects where they were supposed to implement and detect anomalies, detect deep fakes, detect or implement ML models to predict better, better implementations for the cybersecurity features. And I could see that the generative AI has actually helped students to implement such projects. So in that implementation, even if they're implementing it, if they're coding it, that's fine. But then even in that implementation, if they are incorporating the agentic AI, that makes a whole lot of difference. So that was the tipping point where I have started exploring. My students were working on various different tools for cybersecurity, and that time I have realized that yes, it can be improvised by integrating the APIs, by integrating the real-time data, by creating attractive dashboards, by giving a solution to a actual problem of deep fakes, like that. So from where there I have picked these, this area where the students can actually work upon. I'm happy that the idea of agentic AI has been maybe I'm expecting that yes, the students must have understood the difference, and it's not about the new thing, it's about incorporating one more layer of understanding in the present workflow, adding one more decision reasoning by the agents. So that way it is going to, the evolution of technology. We have seen last 15 years, we are already seeing this happening. So the same way. So thank you so much. I'm also glad being part of here, and I'm not talk much now. I'll end my talk here. Thank you so much. Thank you.
Thank you.
Thank you so much, Dr. Vandana. Thank you everyone for coming in for today's session. Hopefully we'll see all of you guys in the next one. Thank you very much.
Good night, everyone.